So good afternoon, everybody. My name is Yusuf Khalidi. I'm from Microsoft. Today's presentation is about so-called hybrid applications. So this is all about taking applications that you may have on premises, in your data centers, that is, and you want to start moving to the cloud. In practical terms, you will probably not move everything from day one to the cloud. Instead, you'll probably keep some stuff on premises, maybe extend them in some way or the other to the public cloud. So I will spend some time defining what this really means, why you may want to do it this way, and some of the options. We basically have a rich set of services to help you, to aid in this function, basically. Okay? Now, this is a small room, and it's not that full, so you can stop me while I'm talking. We can answer questions. I don't think I will need all the time, so we have plenty of time for Q&A. Okay? So what are the objectives of today? Really two objectives. One is understand when you will need such a thing as a hybrid application. When does the scenario make sense? Why you want to do this one, if you will. The other one is when you know that you need to go and do a hybrid application, what are the methods? What are the techniques or the components you could use to actually build such scenarios? And the main takeaways I would like you to leave with after we're done today are the following. We do provide a rich set of services that you can optionally mix and match to build your application. You can always do it from scratch, but instead we give you some stuff to actually make your life much easier. Second takeaway, in principle, this whole business of a hybrid app is really a compromise, a balance among cost and performance, and specific needs sometimes when it comes to regulations and where your data may have to reside, and so forth. And lastly, as with almost many other things in our business, it's an engineering problem here. Specific requirements will be driven by your business. So remember that comment. If you can remove stuff to the cloud as is, just go for it. Otherwise, look at your business needs. If you have to keep your data on premises, for example, and we'll figure out what the best way then to connect them to the cloud properly. Quick agenda, definition, motivation. When would you basically apply the hybrid IT model? The bulk of the presentation about the second bullet. What are these services? We have like 5 services or categories or so I'm going to go through, show you examples of how to use them. Then I will do some case studies. Show you 2 internal case studies from Microsoft IT department. Our IT department basically was faced with some problems that you may be faced with, having legacy applications and how to extend to the cloud. And I'll show you some 2 cases from customer studies where they had to do the same thing. Lastly, some feedback we got and where the gaps still are, because we're not done, actually. Okay? So let's spend some time doing some definitions, then we'll go through the actual technology. This is a basic slide to go through what some people view the public cloud as good. You know, what the public cloud is good for, if you will. This is a view from Gartner in particular. This is a simple segmentation of applications that you may want to do for the public cloud. Just quickly to give you a flavor of this. There are many so-called cloud native apps. These are architected specifically for the cloud. Think of your big social applications. Think of any application that you or someone have written for the cloud properly. Typically, they go to a public cloud because they're growing very fast. If you are in that category, go for it. The rest of the presentation is kind of boring for you. Seriously. I mean, if you're just going to write it all from scratch and you're going to live in a public cloud, that's actually my preference, should be your preference. But even those, you may need to go connect back to something on premises. Second category, think of line of business apps, stuff you may have on premises in enterprise that you want to extend or move partway to the cloud. You may want to move the front end, some business logic, but keep some stuff on premises. And typically you do the same because you have predictable bursting or perhaps seasonal usage. And one of the case studies I will show you from Microsoft IT is exactly that. It's an application that we have usage for it internally twice a year, exactly twice a year. After Christmas and sometime in the summer. It's our performance review tool. Big spike during these 2 months, and otherwise it remains more or less dormant. So it's an example application where we move part of it to the public cloud to get the scalability when we really need it. Other apps, of course, you have e-commerce applications, very much suited for, appropriate for the public cloud, if you will, even though those may have to connect back to on-premises. Test development scenarios are very common on our platform, by the way. We have many customers who integrate their nightly builds and testing with the public cloud. It's an example. You have to do some stuff on-premises, you go burst to the cloud and come back. This morning, I gave a talk about disaster recovery, which is another scenario for which the public cloud is quite good, where you may want to link your applications, which are running on-premises, and use the cloud either to back up your data or as a place to run your applications in case of a disaster. Or frankly, vice versa. Have your on-premises site as a destination in case the cloud is gone for some reason or the other. Lastly, there are class of applications with batch computing. We have, in our case, many customers who are, for example, financial sector. They do risk analysis of portfolios, high-performance computing, and the like. These are very batchy applications. You can be developing on-premises using something like Windows Server, high-performance computing edition, and then when you want to do a big run, you go to the public cloud. Okay? For most, I will be discussing today fall more around the enterprise scenarios. More when you have a line of business app that you want to go and extend to the cloud, or mobile device access to existing applications, which is a very common pattern we see, where you may have an asset on premises, your internal inventory system, your internal system that you want to export or expose to new devices, new clients. So along this spectrum here, there's a spectrum from traditional systems, the stuff we also started with many years ago, includes Windows systems, mainframes, Linux, whatever you have. These are non-virtualized applications. There's a private cloud that you may have on premises, being built using your favorite virtualization stack, all the way to the public cloud, which for this presentation we're talking about Windows Azure here. A hybrid app is an app that has portions of it that spans one or more places here in the spectrum. And more precisely, something that's around the traditional private cloud and the public cloud. Typically, you have the data on premises or some part of the data on premises and the rest in the cloud. You see examples where it's more of either a mixture of these two. Okay? So again, a hybrid app is something that spans that spectrum. A portion is available maybe on premises, maybe it's legacy, maybe it's tied to the existing data that's hooked to your legacy ERP system, for example. And you're extending it one way or the other in the cloud. Okay? And again, I'll show you specific examples to make this thing concrete in a second. Key to realizing when you need to be in this camp and what you have to do is look at your application portfolio in general. There are cases where you'll find out that for a number of reasons, and here's some reasons, you need to consider evolving your app to be a hybrid app versus purely on premises or purely in the cloud. And some considerations you have to do for your portfolio include what's on the slide. How relevant is the app to your organization? Do you want to invest in it, or do you want to just keep it where it is? Performance. Which part of it must stay on premises, close to your existing data, close to your ERP example, for example, application, for example, and which part can go somewhere else? Which part do you want to be distributed in the cloud for performance as well? How mature is the app, or how mature is the component of the app? We find in our customer base, when there's an inflection point, you need to go update the application, maybe version it up, or add new features. That's a good time to take a hard look at the app and say, can I move it to the cloud, part way or in whole? So the maturity is one of those points you look at. Compliance. You may be under some compliance regime, some policy by your government, your company, your CIO, whatever the case may be, that require you to have your data in a certain place. Typically on premises within your data center, behind your firewall in your country, for example. Yet, you may be able to extend it in one way or the other to the cloud by exporting the right subset of the data, for example. So compliance is something that usually is not technical at all, really. It's just a requirement that may dictate you to have require you to have a hybrid application. And I touched on rewriting and migration of applications. Basically, you find yourself in places where it's time to migrate an application. It's time to move it. And that's a good time to do the re-architecture piece. Lastly, and this may sound kind of boring, but actually quite real in real life, is hardware refresh cycle. If you or your company invested into existing on-premises systems, you probably don't want to move to the cloud anytime soon, right? But a time comes, 3-4 years, where the machines are depreciated, and you want to do something. You have to refresh the hardware. That's usually a good time to look at which pieces should I keep on premises, refresh the hardware, and which pieces should I move to the cloud. The cloud gives you a new option here. See, that line at the top, by the way, guys, is nothing new. It's what we have to deal with IT all the time. There's always hardware refresh cycles. There's always a need to migrate, add new features, and so forth. All we're saying here is that when those inflection points happen for your application portfolio, consider the cloud as an extension point for your on-premises, either to move the whole thing or part of the thing to the cloud. Okay. Let's talk specifics about the Microsoft Cloud. This is more of a couple of slides to give you the lay of the land. Then I'll tell you more about the actual technology pieces we have. Okay? So the public cloud, you're probably bored by hearing about Windows Azure already. This big thing in the cloud, etc. Be happy to talk to you offline about it. I was one of the original people who built Windows Azure, so I know it too well, if you will. It's a big investment for us in Microsoft. It's a multi-billion-dollar investment. It's available globally, multiple data centers, and so forth. Of course, we also have the private cloud, which is when you have to have something on premises, when you want to customize it to your needs, when you want to connect to legacy systems, when you want to have the best performance and tune it to your needs, you build a private cloud. When you want the scale, elasticity, offload the work from your system, basically, you go to a public cloud. We strongly believe that the complete spectrum is necessary for the foreseeable future. And our strategy is to continue to offer you the complete spectrum from on-premises, the ability to build your own private clouds using Windows Server and Hyper-V System Center, as well as have the public cloud using Windows Azure. Now, we're not just offering you two separate things and say, yeah, go figure it out. We actually offer them with common technologies between the on-premises and the cloud. The whole idea, the whole premise is that if you invest in this stack, you'll have common technologies that will help you move back and forth between those ends of the spectrum. And the common technologies are basically identity, the virtualization stack, management, and development. And just to make sure we make this very concrete, identity is key, guys. You'll find out in all these scenarios, when you are moving to the public cloud, you still need to manage identity. You want single sign-on scenarios to work. You want your credentials from your enterprise to extend seamlessly to the cloud. Your customers will not be happy, especially if you're in an enterprise setting, if when they access the part of the application in the cloud, they have to know it's in the cloud. It should be seamless. It should be as if it's a local application. And the key is a common identity infrastructure. We have quite a bit of investment in AD in particular, plus technologies, which I'll touch on later on, to do identity federation with third-party identity systems. Okay? So identity is a key component that's common across the spectrum. Another component is a virtualization stack. So throughout the spectrum, we're talking about the VHD format for our VMs. We're talking about the same system that modular your dependencies. You have a lot of flexibility in building your application in such a way that it can move between on-premises and the cloud and back. Now, this cartoon is overly simplified, to be quite frank with you. Apps are not as simple as, I just move them back and forth and we're done. But what this thing is trying to say is that there are multiple scenarios where we can do this simple cartoon of actually having a self-contained VM moving back and forth. Or more likely, the investment you have done in the tooling, in the management investment and so forth, is equally applicable throughout the spectrum, with some modification depending on the case. Okay? So summarize. Second component is a common virtualization stack, common virtualization tooling and the like across the whole spectrum. The third piece is management. And the basic idea, and I'll show you examples of this in a second, is you can use our in-house System Center application suite, if you will, as a single pane of glass to manage across the spectrum. You will see some technology today in System Center, and more coming for it to be the window, the view, if you will, across this whole spectrum. Please note, you don't have to use System Center. Okay? The whole APIs which System Center is built on is actually available to you as well. You can script them and so forth. But there's a richness of tooling in there to help you be the single pane of glass to manage the whole spectrum. Monitoring and management. Lastly, and very importantly, is development. For the developers of us in this room and for our ecosystem, we are very serious about making sure our developer ecosystem and our development tools span the spectrum from on-premises to the cloud. And the idea is very simple here. All the plumbing I'm telling you about, a private cloud, a public cloud, is just plumbing, just a bunch of OS bits and the like. They only light up with applications, of course. So bringing the ecosystem, all the programming tools, all the developers, all the knowledge that we have all invested in to the private and the public cloud is key to the strategy. And this is actually true in many aspects today. You can fire up Visual Studio. The same code for a class of apps is very much the same between on-premises and the cloud. You have to tweak the config settings a bit and so forth, but it's very portable application set. And you're going to see more portability aspects coming into our tooling as well in the future. So just to summarize, guys, for us, we believe that we all need this complete spectrum. There are needs of application that has to stay on premises, have to evolve, have to grow on premises because of regulations, because of latency to current systems, or whatever the case may be, and for which we have the private cloud offering. And we have the extensible, highly scaled managed system, which is the Windows Azure as a public cloud. And they're all linked together with common technologies that you can invest in and apply equally to that spectrum. Okay? So let's talk about now the specifics. So just to go back a second. So I told you about, we have a public cloud, private cloud, and so forth. But if you are really faced with one of those problems, where you have to take an application and make it a hybrid application between on-premise and the cloud, you'll have to connect them somehow. You have to connect them at multiple levels. So what I will show you in this slide are the optional components we have today. It's not a future slide, this is today's slide, that you can mix and match to get your job done. At the lowest level, we have technology called virtual network, Windows Azure Virtual Network, that helps you to build secure site-to-site virtual networks. You can carve part of your local network and make it part of your public cloud. I have a slide or two on this in a second. And by the way, if you want to know more about this, the next session in the next door session is all about that one line, that one side of the picture. We also have secure machine-to-machine connectivity, which cater a lot to developer scenarios, where you can take your machine, your laptop, for example, and securely join it to a virtual network in the cloud. And again, I'll tell you more about it in a second. We have application layer connectivity solutions, messaging and queuing and eventing. And I'll show you multiple examples how we use that technology. It's called Service Bus. And it's key to connect assets you may have on premises and expose them as endpoints to assets in the cloud, to the devices as well. I'll show you multiple examples of this usage in a second. We have data synchronization technology for SQL, where you can synchronize SQL databases, tables from on-premises to the cloud or cloud to cloud and vice versa. And again, as with other stuff on this slide, they're optional. They're tools for you to use in your solution. And lastly, we have multiple modules, multiple components of System Center that you can use to manage applications, monitor applications, and manage your people managing the cloud. Okay? So what I will spend the next few minutes on is I will go through each one of those and give you a slide or two and a flavor how you can use them. And I will confine my discussion to here and now, what we have today. Okay? You will see for each one an investment roadmap in the future. After I go through these, I'll show you case studies, or how actually people have used these technologies to build solutions. Okay? That's the plan. So let's do it the bottom up. Okay? I'm a software guy, like architecture. Bottom up sounds good. Actually, I'm not being totally correct here. Let's talk about Connect first. Connect is a way for developers to, as I mentioned, in a very simple way, take a machine you have, typically a developer machine, and join it to part of the cloud in a secure fashion at the network level. So you can make literally your laptop now. You have to install an agent on it with the proper credentials. You can make your laptop part of the network of your assets, your VMs in the cloud. So all tooling works. You can ping them, you can connect to them, you can run low-level protocols, whatever the case may be. It's very easy to set up. Again, you have to install an agent, you have to exchange some credentials, you're up and running. The main scenario is for developers. We've had this thing for a while, by the way. It's still in beta. It will graduate from beta, but it's still in beta. And it's very useful, as I mentioned, for those kind of scenarios. The downside of it is it's really, for those simple scenarios, it requires you to install an agent on your machines, which scales fine for a developer machine or two. But if you want to have a site-to-site connectivity, and you want to carve part of your enterprise network and make it part of the cloud, you need the other solution, which is Windows Azure Virtual Network, which is new. We announced this thing a couple of weeks ago. And again, the next talk in the other room will spend an hour plus on this one slide. With Virtual Network, you have complete control here. You can take part of your on-premises network, carve out basically part of the public cloud, and create a virtual network in the cloud. If you want to, you can choose the IP address ranges in the cloud to be a subset of what you have on premises. So you may have 10.x private address spaces. You can extend them to the cloud. There's no conflict. We virtualize the whole thing. And you connect them in a very scalable fashion to your on-premises network using off-the-shelf VPN devices that your IT department, your networking folks already have. We have support for Cisco devices, Juniper devices, a bunch of mechanisms. And if you haven't seen a demo of this thing, please come downstairs and we'll show you a demo. It's scary easy to configure. Yet, the policy control is with you. We actually, one of the steps, we give you the actual configuration settings for your device, depending on the make, brand, and so forth. You give it to your folks on premises, they control the policy, you end up with a VPN tunnel, and you're off and running. It's very powerful, by the way. This tool plus the IaaS stuff we announced, all the virtualization stuff we announced, these two tools alone can allow many, many enterprise scenarios to actually happen in the cloud now. So again, guys, I encourage you to go to the next talk if you want to know more about this one. Some scenarios for the virtual network include the basic premise is a hybrid scenario between the public and a private cloud. And frankly, it's between the public and anything. You don't have to have a virtualized network on premises. It could be anything. It could be running a bunch of mainframes or Linux, or we don't really care, to be honest. So you basically connect your enterprise applications to part of the cloud securely, by the way. So that network in the cloud is actually part of your network. You can use it for scenarios like enterprise identity for AD. You can put, for example, read-only AD in the cloud and synchronize and look through a network as if it's one network. I'll show you an example with SharePoint in a second. With virtual network, you can use off-the-shelf tooling for monitoring, management. It's virtually your local network. The only issue we have is, of course, physics, latency. Okay? So logically, it's the same as network. If you have a very chatty protocol, you're going to go through a long distance. But beyond that, it's your network. It's all virtualized. And there are many advanced connectivity requirements that you can go meet using this solution. Again, it's V1 of this technology. We're going to improve it. But we have a bunch of documentation online to show you examples of how this can be used. Yes, please.
Is there also a document for security managers to show them, I hope this is secure?
We do have at least one white paper with the security model in general. I'll find for you if there's something specific about this solution. Okay, but you'll find out there's a key point here. For this to actually work, your people have to configure your VPN device. You have to give permission to connect to the cloud, right? What we help you with is we give you the configuration settings, the suggested settings for your device. But it's up to you to go scrutinize it, make sure it's okay, and incorporate it within your policies. And we built it in such a way to make sure that you have to go look at it. You can just drop it as is. Precisely, we don't want to go wipe up your devices, for example. And if you talk with me offline, I can show you exactly how this works. But this is the key point here. The policy is under your control. If you don't configure your VPN device, talk to us, to our gateway in the cloud, nothing works, which is key. Okay. So here's an example. This is an example of using virtual network to build an intranet-facing SharePoint. In this example, which is supported, by the way, and everything, your left-hand side is on-premises, your on-premises network. Your right-hand side is the public cloud. In this example, your VPN device is configured to talk to a VNet you created in the cloud. This virtual network basically is something you carve out. You specify the IP address ranges if you want to. In this example, they're actually part of your address spaces you have on premises. So apps will not know, whom they're talking to. As part of configuring the VNet in the cloud, we spin up a gateway for you. It's actually a highly available gateway. It's actually 2 VMs. And you get to configure the gateway. It's an interface for you to configure it as well. So you end up with an IPsec tunnel between your VPN devices on premises to the public cloud. And in there, you run basically your applications. And in this specific example, you can actually fire up SharePoint, front ends in VM roles, talk to, in this case, SQL instances. And in this particular scenario, the front-end traffic is coming through the open internet. That is, you're going through a corporate proxy, going through the open internet through SSL, hitting the load balancers, and hitting your application. There are many variations in this theme, guys. You can do it you can do AD, you can do other combinations like that. We still have some limitations. Like, for example, we don't do internal load balancing. That is, if you want to go from on-premises to your assets in the cloud and load balancer traffic, your load balancer has to exist on-premises. See details like that, which we are moving to remove, if you will. But by and large, this technology really is very powerful. Okay? And again, I suggest for those interested, go to our next talk, please. You'll see step-by-step configuration how this picture and others are actually made. Let me move up the stack now. So I told you in the last couple of sections about, you guys are reading, so I told you about the low-level stuff, okay? Connecting the network for developer scenarios or for enterprise scenarios. You can also mix and match another solution called Service Bus, which is a way to easily connect applications at the application level between different places. The principal scenario on-premise in the cloud, but there are multiple ways. And there are like 3 big scenarios here. Look at the green boxes in there. You can have queues for occasionally connected devices. If you have devices like phones, like tablets, whatever the case may be, and you want to connect to assets on premises, those devices may not always be connected. With Service Bus, you can send a message, we'll queue it until your device comes back, and so forth. Another mechanism is basically eventing. You can have topics and subscriptions to multiple listeners, if you will. You can publish them, you can have multiple people subscribe to them and get the events. And lastly, there's a mechanism in there to actually relay, to connect at the networking level through firewalls, different components, different entities, if you will. Typical scenarios include things like, in this example, you have suppliers and partners talking to different entities like branches on premises, or store branches and like on premises, with some pieces running in the cloud as well. So Service Bus is very flexible that way, and I'll show you at least 4 examples of this usage in a second. Before I move on, the very common scenario usually or typically involves some mobile delivery devices in there. And that's we found in practice to be a very, very common scenario. The other one is that you may have some stuff on premises that you want to expose to the cloud. Endpoints, your communication endpoints. You can put them in a namespace in Service Bus and securely expose them to your partners or suppliers or other applications as well. So you get messaging, durable queues, topics and subscriptions and so forth, and an overlay mechanism to go through firewalls, through Service Bus. Another mechanism, and again, I'll show you examples how you can compose this thing, is something called SQL Data Sync. Data Sync gives you a service, a set of mechanisms in which you can synchronize different SQL instances, be they in the cloud, to on-premises, or vice versa. You can do one-way publishing. So, for example, you may have a master database and you're publishing one way to a different database. Or you can do a two-way sharing between them. The scenarios include sharing data between different locations, maybe aggregating stuff back to the cloud. It's not exactly for backup, although some people use it for that as well. A typical example is you may use it to synchronize your databases for separate between your OLTP stack or system, if you will, and maybe your websites or your decision-making systems, whatever the case may be. So you can sort of distribute the data all over the place. You can combine it with a technology, which I'm not going to discuss much today, called the Azure Traffic Manager, to send traffic to different places around the cloud as well. So you can synchronize data to different places, and then the traffic can go globally to one copy versus the other one as well. So it's quite flexible in that sense. Again, I'll show an example of its usage as well. Then, let's talk about management. There are multiple ways you can use System Center to manage applications and monitor them across that spectrum I keep mentioning, on-premise to the cloud. So, for example, you can manage subscriptions using System Center. For those of you who may have used Windows Azure, the way the basic subscriptions work are very basic. You have subscription for, you can be an account owner or others who can actually use the applications. But that's a very simple role-based access control. You can augment this thing with System Center, where you can give you credentials to System Center, and then it keeps track of your credentials. And then using it, you can control who can access your accounts in your IT department. So you can view all your subscriptions, which could be multiple subscriptions, multiple accounts, and so forth. And you can have more granular delegation of access to your subscriptions. And this is integrated with AD as well. So you have a bit more control over who in your department is getting to your resources in the cloud. Basically, it gives you a funnel, a single glass of pane of glass to manage your subscriptions throughout your Azure accounts across the globe. You don't need the live ID is only when you initially created the subscription. But that's it. Your people don't need live IDs. Your people have the local AD credentials. You can use it also to monitor applications in a hybrid sense across the spectrum. So again, same as before. The credentials you have, you give it to System Center. It looks at all your apps, collects the information, combines it with any MOM packs you may have in the cloud or on-premises, and gives you a cohesive picture of your application. Please note when I say application here, this graph, this tree I'm showing at the end, this is the end-to-end application that you care about. It happens to have components running in the cloud, the blue ones, and it happened to have some component running on-premises. So these are the on-premises components. These are the Windows Azure components. You have a cohesive view, a comprehensive view, if you will. You can drill down in any of them. And what System Center is doing is collecting information throughout that pieces. And it's a powerful way to sort of bridge the divide, if you will, between the on-premise pieces and the remote pieces and so forth. And if you have an investment System Center, this is a relatively easy extension. It's just a service pack to System Center to import all this functionality. Another thing you can do, and this is part of the app controller piece of System Center, is you can actually fire or start applications through System Center, either in your private cloud or a public cloud. So this goes hand in hand with what we discussed a moment ago about keeping credentials and access control and the like. You can basically look at all your assets and decide where your application should be started, either in a private cloud you have or Windows Azure. And actually, it's extensible. You can plug in other third-party public clouds if you want to in the system. So again, this is a way to manage, not just to monitor, but to manage the applications. Start them, change the scalability aspects, reconfigure them, stop them, and so forth. And before I leave the System Center section, again, all this stuff were built over the existing public APIs. So we have a bunch of REST APIs that are documented for managing applications, and all System Center team did was use those APIs to monitor things and to manage things. So you can do some of the stuff yourself. You can combine them with PowerShell. It's your call. It's quite flexible. Okay. So enough of the plumbing. I told you a lot about that. So the strategy, why hybrid apps may be needed or are needed, and I told you about the optional components. Let me show you now examples of how real applications have used these pieces. Okay, and what I'm showing right now are not necessarily perfect answers. Is what some teams went about using these technologies, and in each case they have their own constraints. Okay, there's one app we have within the company called Employee Performance Management, and for anybody from Microsoft, you know about this one. So twice a year at Microsoft, we go through. Every employee has to go through performance evaluation. Submit your reviews, talk to your manager, and so forth. It happens twice a year, sometime after Christmas and around this time of the year. During these times of the year, the load just spikes up. Microsoft has, 90,000 employees or so. IT typically had many, many machines just sitting idle most of the year. 9 months of the year, they were not doing anything. And for those 3-4 months of the year, load was really spiking up. So they decided, let's take part of the application, the part they could do very quickly, and move it to the public cloud and make it very scalable during those times of the year, during the tough times, if you will, the high load ones. This is the picture of the application before the change. It was a big application, 80-plus person years of engineering effort. It had a large investment in hardware, like I mentioned, which was mostly idling most of the year, except for these 2 short periods where the load was quite high. It all lived within our corporate network. So you cannot hit it from the internet. It has to be within the corporate network. You don't see it anywhere else. Has a lot of front-end stuff for the websites, for the web services piece, a bunch of foundational services, and a back-end, which is heavily SQL back-end. And note toward the right-hand side there, it also hooked up to existing ERP application, in this case SAP. I can tell you SAP is not moving to the cloud anytime soon, not this SAP implementation. So this SAP, you're going to stay on premises. There's some stuff for employee configuration, employee data will stay on premises. So what to do about it? So they found a nice line to move part of it to the cloud and part of it to stay on premises. So this is what they did. They took a hybrid approach. They put all the front ends in the cloud. They kept SQL on premises. They put some SQL Azure in the cloud for logging, some metadata, and the like. And in this case, used Windows Azure Connect, because Virtual Network was not available yet, to connect the databases, and Service Bus for most everything else, and ADFS for identity. So they did 2 things, basically. Took an opportunity to re-architect the application a bit. Better layering, better interfaces, and the like. Then use Service Bus to connect basically all the WCF interfaces between the components in the cloud and on-premises. And using Connect, which is in this case a more primitive version of virtual network, to connect the front ends to the back end, to the data, basically. Okay. Again, the use of Connect here, don't use it this way, guys, in production. They had to do it because virtual network was not available yet. In this case, you have to install an agent in every SQL machine, not really an appropriate solution for real. So they're moving actually to virtual network as we speak. So in this case, by the way, there's a detailed case study on this thing. There's a video, a link in there, and documentation of where the cost savings were. Now, I'm double-clicking here on the usage of Service Bus in this solution, where Service Bus was basically used to export endpoints, bindings, from on-premises, from the bottom box to the cloud piece, without changing the code. So locally, you have on-prem service calls, usual stuff, basic WS HTTP binding endpoints. Plus, you have endpoint bindings from the cloud to on-premises through Service Bus. So the code thinks it's talking to a local WCF endpoint, but it's actually the endpoint is exported in a secure namespace in the cloud, and you connect to it either from outside in or other way around. In some cases, they were. The question was, your legacy application was web service enabled. In some cases, they were. In other cases, they wrote a shim on premises to make them as such. And that shim talked to Service Bus. And the other example, I think the shim may be even clearer in there. But you're correct. If they're already web service enabled, it's much easier. Otherwise, you have to write a small shim on top of it. Small or big, depending on the case, actually. So again, if you're interested, guys, go to TechNet, and you can find a video in there and more documentation and case studies of how they had to go through this whole thing. So this was an example in which, frankly, all of Microsoft depends on. And if something goes wrong, my phone rings and other people ring. So it was a very interesting experience for us. The other example we did, and this is actually a mission. This one is called BC Web. It's part of a mission-critical application for Microsoft. BC Web is part of this business case web application. It's part of volume licensing for Microsoft. This is part of how Microsoft gets paid by its customers. If this thing has a problem, we don't get paid. And this thing has moved to Windows Azure. To be honest, this is part of the whole complete volume licensing suite of applications we have. They decided to move one piece of it. And I'm going to show you now the end game, not the steps to get there. So one aspect is you need to be able to get to it from corporate through single sign-on scenarios. And EDFS was a solution here. So remember, people just go on our corporate network. They want to be able to log on to this application, do the quotes for volume licensing stuff I don't really understand. But technically, they want a seamless experience as if this thing never moved to any cloud. So you need to have a single sign-on experience to go smoothly this way. They have two pieces in the cloud. I should not go this fast. There's a service, which has basic building blocks from Windows Azure, web roles and worker roles. And the code was basically ported, but it was a very simple port for them here. They also use Windows Azure Cache for caching state. They move some state in the cloud in SQL Azure, which you'll see in a second is being synchronized with a copy on premises. There's another service that does more, if you will, business logic as well in the cloud. And they all connect to those SQL Azure databases. Now, Service Bus comes to help rescue again here, if you will. So in this case, to answer your question, they did add a small shim to web enable some of those services. And these things at the bottom, but they also talk to SAP. So the glue logic is down there. But otherwise, it was Service Bus that took those WCF endpoints and exported them to the cloud and securely connected them to the front ends in the cloud. There's also SQL Data Sync was used to synchronize between databases in the cloud and on-premises, really for two reasons. One, they wanted to have a backup from the cloud to on-premises. It's just, I'm not sure if they had regulation issues, but they really wanted to have a copy as well themselves. And they also ran reports this way as well. So the data was actually in the cloud for this application, synchronized back on-premises. And they also ran some maintenance jobs on-premises that maintained data in the cloud. Note in this example, they did not use Connect or virtual network. It was not needed. In the other example, it was needed. And the reason it was not needed in this case, actually, most of the data is in the cloud and it's only synchronized on-premises. The front end talks to the data directly in the cloud. That's another example. That link in there has more details on there, what they had to go through, and all the experiences we had in getting this application up and running. Any questions so far? So let me tell you about a couple of case studies from customers. And there's more in this thing on the website as well. What they share, by the way, is they use Service Bus extensively, and they both wanted to take existing applications and make them device-friendly or mobile device-friendly. They want to export existing data, if you will, and applications to devices. One was LexisNexis, where they built a mobile version of an application they have called Time Matters. They built the app on Windows Azure, and they built it through the normal stuff, ASP.NET, worker roles, SQL, Azure in the cloud. Then they use Service Bus to reliable messaging to connect back to on-premises, assets on premises. Basically, you had these mobile devices that were disconnected, they could be disconnected, and they needed to get back to data that was on premises. And Service Bus was an easy way to, again, export the endpoints in the cloud. You can drop the messaging in Service Bus. It will queue it when the device is ready. When the device is ready, it will go pick it up from that queue. Very simple, by the way. But it really opened up a new application set for them. And if you look at the case study, there was a bit more to it as well, where they had security needs. So they controlled how the data was being exported. So what they actually had in this case was a bunch of the front ends were running in the cloud, but data itself stayed on premises. There was a nice mixture in there. EasyJet did something else. If you use EasyJet, by the way, and you notice how when you go check in, they have mobile devices in the airports and the like, it's all running on Azure. What they wanted to do was not have to go and depend on local networks from every airport, rent these expensive terminals from airlines, and just do it themselves. So they had their own IT department, their own systems, but they also wanted to be able to, agents to check you in with devices without having to go configure the network in every airport. Go to every IT department and give me a VPN, what have you. So use Service Bus for this. They exported the endpoints of their application, which is running somewhere else, as endpoints in the cloud through Service Bus, securely. They look like bindings in the cloud, by the way. And your devices connect to those bindings. And voila, you're done. So they use the local network as a dumb Wi-Fi. No VPN, no IPsec, nothing. And you know that this company has many airports. Some are not necessarily the fanciest airports and the like, and they can do it bypassing, going through, legacy systems and classical airline infrastructure, if you will. The case study has more details in there, and I can show you more stuff as well if you want to offline. Any questions on this? Yeah, because I'm talking very quickly, I'm almost done, so I was hoping you guys stop me and ask the hard questions. Okay, guys, so what have we learned? What we have heard so far? And I'm giving you the honest truth here from those teams. Again, 2 big teams within Microsoft and 2 customers. But we have at least 100 case studies documented Windows Azure usage. But I want to show you more the hybrid scenarios at the moment. So what worked well? Most of everybody liked the consistent and managed way to run the system. So, especially if you write things to the so-called web role or worker role in Windows Azure, we manage the OS for you. We manage patching of the OS for you. It's a simple environment. You write the code. We take care of the other stuff for you. And people really like the stuff. Not only do we stand up the VMs for you and do the hardware and the like, but we also manage the OS environment for you as well. People really like the ability to leverage existing projects, especially web projects, and existing expertise. So all these cases I told you, they took current stuff. And almost like all cases, they have to change something. Write a shim on premises to export WCF endpoints, or maybe move some ASP.NET code from on-premise to the cloud, change the config settings and the like. But by and large, it was a relatively easy experience. The hard part, by the way, was to figure out what needs to be done first. How to take the app and where to put the line in there, where to keep the data and so forth. People like the ability to spin up new environment and instances. It's actually quite easy, as you may know. In that the infrastructure is there, you need more capacity, you just go up and run, the stuff is running. Worker roles are very powerful. If you do not need persistent VMs, use worker roles, because you can run anything in Windows that doesn't require persistent, if you will, C drive persistence, if you will. Okay? And you get all the benefits of the platform managing the OS for you. And as you could tell from the many examples I gave, Service Bus was very powerful for application-level connectivity. If you need low-level network connectivity, use Windows Azure Virtual Network. It's the big hammer that can give you the actual network connectivity. It looks to you like a local network. Protocols just work, you're in the local network. If you're in an example like the EasyJet example where you don't want to go muck around with IPsec and talk to different people and so forth, and you can do it at application level, Service Bus is the answer. You can mix and match, by the way. Okay? And by the way, Service Bus has other scenarios which have to do with if you have multiple partners who want to talk to each other, you want multiple people coming to the same, different places, you want to rendezvous on the same endpoints, Service Bus is the answer, really. Now, and honestly, some things did not work very well. So we are still not very good when it comes to the management experience, especially for a first-class enterprise experience of managing your assets, role-based access control, who can do what in the cloud and so forth. The example I gave you of System Center is the first step we've done in that space. But we're still not totally there yet. So unless you use System Center, you end up with Windows Live ID, with an admin, and an account owner, and we know that's not really sufficient. We're working on it. Okay? If you have a team of more than one person, it's a problem. We know that. Deployment time continues to improve. We are down to, on average, 50th percentile, maybe 8 minutes, 6 minutes to start a VM, depending on the case. What we have improved the last year or so, if you have used Windows Azure in the past, is the long tail. So the 95th percentile of deployment time went down considerably. We're not done. We will improve the deployment time. Monitoring and health visibility still continues to be something people want more visibility into. So with the integration System Center, that helps. We have more monitoring support now. If you're familiar with the new portal, you're going to see more investment there. It's something we keep hearing from customers about. This next to last bullet was a problem. We don't have a problem anymore there. Everybody wanted site-to-site secure connectivity. This is what Windows Azure Virtual Network is all about. The example I gave you from MSIT, where they use Connect with an agent between the front end and SQL, was a stopgap solution. Not a real viable long-term solution. You cannot go install agents in your SQL databases or AD. Okay? You do it at the network level. And that's what Virtual Network is all about. Lastly, and again, I'm just telling you truth advertising here, we still lack enough or good number of enterprise-ready samples here. I showed you some very cursory slides here. We need more of this. And you see more stuff coming from us. Why am I showing you this list? Because these are basically the stuff we're working on. So take this thing as an indication of what our roadmap is as far as this space is concerned. Okay. Any questions? Okay. Actually, my last slide. So hybrid apps, in summary, are a balance among cost, performance, and time to market, and also control. Where do you want to keep your data? Where you are willing to keep your data somewhere else in the cloud, for example. So think about them when you are at the juncture of re-architecting an application or trying to use assets you may have on-premises, like data, for example. Okay. And to be honest with you, if you're writing a new app from scratch and you want to be very highly scalable and you have no need for any on-premises stuff, ignore virtually everything I told you today. Seriously. Go to the public cloud. It's better, it's easier, it's more scalable, and so forth. But life is more complex than that. We all know that. So when you are faced with a complex situation, here's the list of technologies we have today to connect on-premises to the cloud. I mentioned virtual network, a very powerful solution that lets you effectively extend your enterprise network security to the cloud. Another one is Connect, good for developer scenarios. Service Bus, Service Bus is hard to explain at times because it can do so much, by the way. So when you look at it, choose a scenario you want to. Data Sync is a tool for data synchronization, of course, System Center for management purposes and monitoring of applications. I failed to mention, of course, but we have PowerShell and REST interfaces that are very useful to stitch together management across the spectrum as well. Okay, so it's all available from any device. You can compose them into build very rich services, and if you go through the different presentations during this event, you'll find different scenarios where we have put together AD and SharePoint and SQL in the cloud, connected to on-premises one way or the other. There are multiple ways you can do that. And I'll give you a list of the session in a second. Lastly, it's important to remember, we are still beginning in this space. We're not done. We have features coming for virtually everything on this bullet. I can tell you for a fact Virtual Network has more stuff coming, Service Bus, and etc. So you'll see more in this space as well. So some content, we have a lot actually in this event around this theme, not necessarily labeled hybrid per se. And we have more online as well. So we have a couple of presentations about Service Bus, and we have the next presentation next door about Virtual Network. Okay? Because I'm done actually, and we are 19 minutes early, which is fine with me. The questions, please. I'll be happy to answer anything you have to. No questions? 2 questions, please.
Does Service Bus have main performance optimizations like compression or something?
Question about compression Service Bus. I cannot doubt it, to be honest. I can check with you offline. We have people here. I haven't heard anybody complaining about performance per se, to be honest. But theoretically, it has a potential to do that, if you will. It has multiple bindings for the endpoints. So the question really depends on what the binding implementation is like. So I can probably get you offline on this one. Question?
Are there scenarios possible where you have on-premise web application and you just want to add additional web applications on features in the cloud? Because in the picture I saw you had a load balancer on the cloud.
Yep.
How does that work? You still want to add something on-premise as well?
Good question. Specifically, just to repeat the question is, if you want to take some front ends and keep maybe some on-premises in the cloud, how you do load balancing between them. Today we have some limitations, to be honest. So for load balancing, you either use our load balancing infrastructure to load balance to a bunch of front ends running in the cloud, or use Virtual Network, use your on-premises load balancer to load balance everywhere, on-premise and the cloud. Basically, what we're missing is the third option of using load balancers within Virtual Network. We call this thing internal load balancing, and it's coming. It's on the roadmap. So just to summarize, to do your scenario where you want to keep some front ends local and some in the cloud, you want to load balance between them, you can make it work with Virtual Network, but you have to use your load balancer. Load balancer, you can spray the traffic this way and in the cloud. And the policy is yours. Okay, guys, I'm around if you have any questions. Please come downstairs, see demos if you want to how this stuff really works. Thank you.